Good morning, everyone.
Good morning, sir.
Is my screen visible?
Yes, sir.
Yes, sir.
Okay.
Sir, I have one query in this.
Yeah.
We declared a variable y, right? Hmm.
One
Scroll
second.
down.
Can you tell me the line number? Just hold on. Let me open this file. Yeah.
One second, I'm also opening it. We declared one variable y. I don't remember the line number, but we declared, yeah, this by CSS.
Yeah.
So this is going to be a y variable, right?
Yeah. This is the y variable.
So for all the equal, like all the case studies which we are going to have, we are going to have only one y variable, right?
Yes.
And that will be mentioned in the case study. Based on that, we have to figure out the features.
Yes. Either it will be mentioned explicitly or it will be mentioned in the problem statement. And from the problem statement, you can figure out which is the y variable.
Okay. And one more thing, these are the in general steps which we are doing for the linear regression, right?
For linear
Like-
regression, these are the not
Like-
in general steps. These are the typical steps.
Yeah, the process to get to the final
Yes.
the model. So these are the basic steps we have to follow it, right?
Yeah.
Okay.
I mean, there are other, we haven't completed it yet. We still have two more things to go. For example, let me check. Where did we stop last time? We did this. Yeah. So we came. Okay, we have done till the prediction part.
Yes.
So there are two more steps, that is checking for we have to do the cross validation. In fact, the cross validation should come before the prediction. And we also have to do the transformation of data, which will come after the prediction. So these are the two steps pending that we'll do today.
Okay. Sir, one more thing. When I was trying to execute the whole page at a time, I was getting some errors.
Can you share your screen, please?
Yeah, I'm sharing one second. I don't have the sharing access. Is my screen visible?
Yes.
Okay. So, so this is the whole program.
Okay.
And this is yeah, this is to run a file, this F5 condition. So if I click over here, I'm getting, okay, now it's running. Okay, fine. Oh, that day I was running, I was not able to run. I was getting this fact grid object has no attribute set label y. Here we have set label y.
Wait, I'm just checking, where are you getting that error?
Line number 121. This one.
Okay, SNS dot dist plot data of C set underscore YLABEL. No, this is what is SNS?
It's one of the libraries.
Just ensure that you have not,
Seaborn.
just ensure that you don't have any other variable called SNS. Can you just do a search on SNS?
No other variable, just a library.
One second. So SNS dot set, okay, font scale, this is fine. Color code is true, okay. Then you have fig dot add underscore subplot rows, okay. Then the C type equals H. Then SNS dot dist plot data of C dot set underscore Y label facet grid object has, why is it saying facet grid object has no label?
In the net also it was saying something to import, but C1 was taking up, so I did not went through
Now,
further.
have you imported the matplotlib library? Just check.
Yeah, matplotlib.
Can you just run line number 16? No, it should not give an error because the only
what I like understood, like if I run that function before calling it, it executes. Suppose if I have to execute this function, check normality. So if I select this and after that I'm checking normality now. So if I select this and execute this particular selection, it will execute, and then I'll call this function over here. It will give me the output. This is my output. But if I try to execute everything at a single time, it gives me that error of fact something. Fact grid object has no attributes.
Okay, do one thing. This set underscore Y label is coming in the next function, I think, plot charts.
Yes.
Can you run the plot chart function? Just that, select. First compile this function. Okay,
I'm not getting an error.
Now the function is compiled. Now can you run this line 135?
Yeah, I'm getting.
Okay, so I think the problem is this variable called this parameter called set Y label has been discarded in the new version.
Okay.
So you can just comment out that portion after that. Yeah, from there.
How to comment that?
Hash.
Okay. And how to comment the multiple lines in it?
Three single quotes or three double quotes?
Three single quotes.
If you go to line 134, suppose you want to comment out 135 to 137. Okay, so put three single quotes in 134. Okay, and then 138 put three single quotes. So that entire line.
Okay, got it.
So that is multiple point. Now compile this function.
Yeah. It's changed.
So that
Y
parameter
set
set
label.
Y label will only display the text, that is which column you are drawing that histogram. So that is the purpose of that set label. So I think they have discarded this usage.
Okay, sir. Got it. Okay, sir. Okay, thanks, sir.
Fine. So just wait for some time. I think others are still they will be, so any other questions from anyone? Kamlesh, Tejas? Okay, we'll just wait for 5 minutes, and after that we can slowly start.
Yes, sir. And sir, one more thing. Do we have any online sets for practice? Like, yeah, that I was searching for it, but I did not got
Yeah,
any.
I will tell you. I'll tell
Pankaj,
you
I'm
the
sharing.
website
Okay.
where you can find some data sets.
Okay, sir. Thank you.
Sir, सर शेयर स्क्रीन करूँ क्या? हेलो. सर
Yeah, didn't anyone call?
हाँ तेजस बोल रहा हूँ मैं।
हाँ तेरे, हाँ
सर क्लासिफिकेशन में आपने सपोर्ट वेक्टर मशीन होने वाला है क्या, और डिसीजन ट्री
हाँ डिसीजन ट्री है ना।
और सपोर्ट वेक्टर मशीन और जो रैंडम फॉरेस्ट?
हाँ तीनों है मेरे ख्याल से सिलेबस में।
ओके। मैंने एक किया था सिंपल रिग्रेशन में, वो दिखाओ क्या वो करेक्ट अप्रोच है क्या नहीं?
या श्योर। एंड कैन यू प्लीज कॉल द अदर्स अगर इन केस दे हैव,
चलेगा।
एक मैसेज कर दीजिए उनको सो दैट दे कैन आल्सो ज्वाइन।
सिंपल है
ये रिग्रेशन है।
हाँ, सिंपल लिनियर।
ओके
ये नॉर्मल किया था अप्रोच, डिफाइन किया वेरिएबल एक्स और वाई, बताया था तुमने वैसा। उसके बाद मैंने स्प्लिट डाटा किया ट्रेन टेस्ट में, तो एक
Okay.
से उसके बाद मैं प्रेडिक्शन वैल्यू टेस्ट से लिया, एक टेस्ट से। उसके बाद मैंने जो इवोल्यूशन मॉडल किया R2² से, और प्लॉट में दिखा जो यही वेरिएबल है इधर बाहर जा रहा है, आउट ऑफ स्कोप जा रहा है, इधर आउट ऑफ रेंज जा रहे
क्या हुआ प्रेडिक्शन?
हैं। ओके गुड है इसका, सब
Okay.
जो अपना लाइन से नजदीकी है सब, ज्यादा नहीं बाहर जा रहा है कोई। और प्रेडिक्शन में ये सब नॉर्मली डिफरेंस कम है, और प्रेडिक्शन और एक्चुअल वैल्यू इज सिमिलर।
ओके
दैट इज गुड, दैट इज करेक्ट और रॉन्ग?
हाँ डेटा सेट अच्छा है, दैट मींस बिकॉज प्रेडिक्शन में और एक्चुअल में डिफरेंस काफी कम है।
हाँ
सो यू नीड टू फाइंड आउट जो आरएमएसई वैल्यू है या एमएसई है वो कितना है।
वो नहीं किया मैं वाई प्रेडिक्शन में निकाला है, उतना ही तक गया था मैं।
हाँ ये ठीक है, अप्रोच इज फाइन।
ओके
अभी यू आल्सो नीड द अदर थिंग्स, जैसे वो assumptions चेक करना है।
हाँ फिल आउटलायर है,
हाँ
नॉर्मल डिस्ट्रीब्यूशन में है।
करेक्ट करेक्ट, वो सब आपको करना है। सो दोस
चलेगा।
थिंग्स, वो सब
और
मैंडेटरी चेक्स है वो सब।
ओके, और
होमोस्केलेसिटी
नल
चेक
में नहीं
करना
थे
है।
इसमें?
हाँ
तो डाटा आता है उसमें पहले जो हम प्री प्रोसेस करके ही लेते हैं ना, जब नल और सब।
प्री प्रोसेस करना पड़ता है, जैसे कुछ आउटलायर हो या वो सब, यू नीड टू क्या बोलते हैं, यू नीड टू फिक्स दोस थिंग्स।
Okay. चलेगा सर, थैंक यू।
ओके ठीक है, आई गेस वी कैन स्टार्ट। मैसेज किया क्या आपने? Shall we start or should we wait? Hello.
Yes, sir, we can start. I think everyone is joined.
हाँ सर, आ रही है बंदे।
ठीक है, I guess we can start. It's already 9:30 now. Okay, so today we are going to do two things. First is the cross validation, and the next is the transformation of data in case if your model is showing heteroscedasticity. So how can we transform the data? And using the transform data, how can we build the model? So there are two types of transformation. One is using the features to transform, leaving the y as it is. And the second concept is using the y to transform, leaving the features as it is, which is called Box-Cox transformation. Okay, so today we will first start with cross validation. Do you know the concept of cross validation? What is the meaning of cross validation? What is k-fold cross validation?
Check the test data.
No, it is not the test data. Anyone? Keshav, Komal, Kamlesh, Manish?
Comparing the RMSE of test.
Louder, please. I'm not able to hear you.
Comparing the RMSEs of training and testing data.
Yes, it is not training and testing. It is only for the training stuff. Now, the concept of cross validation is I have my training data, I have my testing data. Now, model is built using the trained data. And the trained data, after the model is built, we generally do the testing on the testing data. This is a normal procedure. Okay, but how does the model behave when the testing is done on the same data? So what is the performance of the model? Okay, this is called as cross validation. So when I apply the model on the same training data, what is the result? So this is called as the training result. And once I apply the model on the testing data, this is called as testing results. Now, IID, I'm sure you are familiar with this concept of IID, independent and identical distribution of data. So according to the rule of IID, the training result and testing result should be similar. If the training is more, testing is less. Okay, so this is okay. If the testing result is more and the training result is also high, then it is not a good model. But when the training result is less and the testing result is very high, this is overfitting. Okay, so this is what we have to confirm using the cross-validation method. So the cross-validation method uses a technique called as k-fold cross-validation. So the k-fold cross-validation, the training data will be split into k-folds. Folds means it will be split into k different, you can say, subsets. K is a positive integer, ideally greater than 2, greater than equals 2. So if I take a 5-fold cross validation and my training data has 100 records, the k-fold will be split into 5 parts. Each part will have 20 records, 20, 20, 20, 20, and 20. Out of which 4 parts will be treated as a training data and 1 part will be treated as a test data. And it takes turns to get the model training and testing. So out of 5 iterations, so there will be 5 iterations, 1, 2, 3, 4, 5. In the first iteration, the model number 1, 2, 3, 4. So this is model 1, 2, 3, 4, 5. So will be used for the training. The 5th one will be used for testing. So these become the training data and this becomes the testing data. Then the result you get here as result 1, or you can say error 1. Then in the next iteration, one of these records from testing will come into the training. So this will be 5, then 1, 2, 3, then this will be 4. You will get error 2, and likewise till the end of the iteration. So at the end of the iteration, I'll get something called as training error, which will be summation of all the errors divided by K. Okay. Now this training error will be validated against the testing error. So in last week, we have already got what is my testing error. If you look at the code, we have a predict function, and the predict function gives me the testing error. So now I need to find out what is my cross-validation error and check whether these two results, are they close to each other? Are they matching? How different is that? So that is the purpose of cross-validation. So ideally, cross-validation should come just before you do the prediction. That is here. So we will write the function here called cross-validation. Is this concept clear to everyone? Okay. So we are going to do a 5-fold cross-validation.
Sir, K is an independent thing, right? Like it can be 5, 4, 7, anything, right?
Yeah, it is any positive integer.
Positive integer.
Ideally, it should be 3 or more than 3.
So that cross validation K, the value of K will be given in the case study, or we can assume something?
No, you can take any value.
Okay.
You can take the number of, there are different people have different techniques. Some people take the number of features as K, and some people take the total record count and then take a square root. So you can come up with your own formula, but remember that more the value of K, it is going to take a long time, and less value, it is going to not give you a very good result. So somewhere optimum in between, you have to come up with a value. Okay, so usually we go with any number between 5 to 7. Okay, so of course you are free to change these numbers. So we are going to do a cross validation where the K value is 5. So first I'm going to define cross validation mean square error as a list of values. Then I'm going to define the X and the Y. So X is train X dot values. Why is it giving? Okay, so before that I need to run my entire code, only then this will work. Now this will work. Okay. So first create the mean square error. Then create the input array for cross validation. So train X dot values. And Y is train Y dot values. Okay, so this is the input array. So array for cross validation. And this is MSC for every cross validation. Now I'm going to do the number of folds as 5. Do a 5-fold CV, that is K equals 5. Okay, and now KF equals, now if you go to the library part, go top. So here we have already imported this library called kfold under model selection. Okay, so I'm going to use this library called kfold. So K and the number of folds I want is 5, which I have already defined. Okay, so now I'll be split the data and perform cross validation. So for every train index, test index. So I told you that the train data gets split into 2 parts. 4 parts go into train and 1 part go into test. So I want the training index and the test index for the number of folds that I have. So if I have 5 folds, I'll have 5 different sets of train index and test index. So for train index and test index in, now I'll be splitting my data, which is kf.split. And I want to split the training data. The index is going to be the same, whether I take X or Y, because it's a 1-to-1 match. So I'll be getting 2 sets of indexes. The 4 parts will represent the train index. The part remaining will be the test index. So now I am going to take the cross validation train X and cross validation test X separate. So CV train X and CV train Y equals. So from the train values, you take the train underscore index, and from the Y, you take the train underscore index. Is this line clear to everyone?
Sir, that CV underscore train X and CV underscore train Y. That is the train X and train Y data, right?
Yes.
But where did we declare that CV underscore?
It is
train
not
X?
to be declared in Python because
it's a
this value
runtime.
will be
It's a
overwritten.
runtime.
So it need not be declared initially. You can directly create these objects. Okay.
Okay.
So now I have the train data. The number of folds is 5. Okay, now I have the X, then I have the Y. So X will contain the train X and the Y contains the train Y. Okay, now when I use this kf.split, now because the value of K is 5, it will be split into 5 parts. Now in the first iteration, the CV underscore train X will contain 4 paths from X, and CV underscore train Y will contain 4 paths of Y, which I have written here in this code. Similarly, I'll be doing the next one, which is CV underscore test X and CV underscore test Y. So this will contain from the X, the remaining part of the index, which is test underscore index, and Y test underscore index. Okay, so now I have the 2 portions. So this contains the 4 paths, and this line contains the 1 part, which is the test data. Okay, clear?
Yes.
And now remember, this is in a loop. So there will be 5 models built and 5 predictions done, and you will get 5 errors. And the CV underscore MSC will have 5 values. So now you can do the model and prediction for each combination of train and test. So I can use the cross-validation model equals sn dot OLS CV underscore train Y CV underscore train X dot fit and then cross-validation prediction equals CV underscore model dot predict CV underscore test X. Okay, and now I will use CV underscore MSC, which is the list at the top, dot append mean squared error. So mean squared error will take 2 parameters. What is the actual data? What is the predicted data? So the actual data here is CV underscore test Y, and the predicted data is CV underscore pred. Okay, clear? Now I can put all these things inside a function. So define do K fold cross validation, train X, train Y, and you can give the value of K and default it to 5 here. And folds equals K. And then return cross validation underscore MSC. Okay, now let's compile this and see. Okay, so now the function has been compiled. Is this code clear to everyone?
Yes, sir.
Okay, now you can execute the code. So run CV. So you can create a function, sorry, not create a function, the output variable, you can say cross validation 1 equals do K fold cross validation. The data is train X and train Y. Now I need not give the value for K, which is already defaulted to 5. So you can take that as it is. And now if I do print CV1, so now you can see that for every fold, it is giving me a cross validate, it is giving me a mean square error. So for the first iteration, 116.3, for the second one, it is 114. For the third one, it is 113. For the fourth iteration, it is 91. And for the fifth iteration, it is 103.8. Okay, now if I want to find out what is the cross validation mean MSC, so I can use mean of CV1. Okay, so the mean cross validation error is 107.82. Is this clear to all? Any questions? Yes, Ankita, Manish, Keshav, Tejas, Kamlesh.
Sir, once completing this, can you please help us to note down all the steps of building this particular model?
Sorry?
Once we are done with this particular algorithm, can you please help us?
Yeah. Have you done till this point?
I mean, yeah, doing it, but I want to note down all these steps, like what was step 1, step 2, likewise. It will be easy to remember.
That's why I'm putting all the comments here that what is this
Yeah.
doing. So if you have any questions, you can ask. So I'll wait for you to finish and then I'll go to the next step.
Okay, okay.
हेलो।
Yes.
हाँ सर, जो हमने अभी जो क्रॉस वैलिडेशन किया है ट्रेन के ऊपर किया ना हमने सर।
Right.
हाँ, तो जो भी हमारी एमएससी की वैल्यू आई है, अगर वो ज़्यादा वेरी करेगी तो इसका मतलब हमारा जो ट्रेन में डेटा है वो अच्छे से नहीं है, राइट?
नहीं, अभी हमको ट्रेन और टेस्ट को कंपेयर करना है.
ओके।
So we have the train MSC. ठीक है? Then we will have a test MSC.
ओके।
अभी ट्रेन का MSC कितना था? एवरेज अराउंड 107 था ना? So 107. अभी टेस्ट का MSC क्या है तो वो अभी हम देखेंगे. So according to the rule, दोनों सिमिलर होना चाहिए. Not exact, but it should be somewhere close to 107. It could be 106 also, it could be 108 also. So roughly plus minus you can say 1 or 2 points. So approximately same होना चाहिए. अगर बहुत ज्यादा डिफरेंस है, if the train is 107 और टेस्टिंग पे मान लो 50 है, so that means this is acceptable because you are reducing the errors. अगर ये 107 है और टेस्ट पे 255 है या 250 है, so that means it has overfit. अगर इस पे भी 155 है और इसका बहुत कम है, मान लो या मे बी ऑलमोस्ट द सेम है, then this is acceptable. Okay, so this is what we have to find out. ट्रेनिंग और टेस्टिंग पे what is the difference.
ओके सर, थैंक यू।
यहाँ तक हो गया सबका? all done?
Doing it, sir.
Okay. Okay. So now we have the cross-validation error. Now we also have our prediction error. So now you can print both these. So print cross-validation error equals dot format. I won't call this error. I'll put MSC. Cross-validation MSC equals this, and test MSC equals dot format. So cross-validation MSC1 and MSC. Okay, so now you can see that the cross-validation MSC is 107.8, whereas the testing MSC is 112.8. So the difference is not too much. So we can say that there is a slight overfit of the model. What is the error that you are getting? Hello?
Executing the code, sir.
Sorry, how much?
Executing the code. Manoj.
Okay, fine.
Sir, I am getting the error in k-fold function. My output values are different.
One second. Can you share the screen?
Yeah, one second. Is my screen visible?
Yeah. Tell me. Okay, do k fold cross validation train x train y k equals 5 cv msc x equals train x dot values y equals train y dot values.
Why this parameters are different? Why true and why predict?
One second. Let me check. Folds equals 5. So that instead of 5, you can put folds equals k. No need to hard code it. Kf equals folds of this for train index, test index in kf dot split of x. Okay. CV train x, CV train y equals x of train index, y of train index, CV test x, CV test y, x of test index, y of test index, CV model equals SM. CV train y, CV dot fit, CV product, CV underscore model product, CV test x, CV dot MSC dot append, mean squared error. No, it is in line number 222. It is not test x, it should be test y. Because you are predicting, you are finding the mean square error of actual versus predicted. Actual y versus predicted y. Now run line number 228.
Yeah, one second. Yeah, 124.96.
Okay, so now if you see each model is giving you different values. Now, if you take an average of that, that becomes the k-fold cross-validation mean square error. You take an average of that.
Yeah, average is around 113.
113. Okay, so now do the prediction and you can find the difference. Sorry, not difference. Do the comparison of training error versus testing error.
Predict y is not defined. It's already defined.
Spelling mistake. PEDICT. Just make it R. No, give the name properly. No, it is predict. Give predict. Now compile the function again and then do it.
Hundred and 98.
Okay, that is fine. The difference should not be too much.
And what were the conditions to predict it if y is more? Sorry, I mean to say if like we predict nights overfit or not suitable and all. What were the conditions for that?
No condition as such. You just need to find out the difference between the two errors. They should be similar to each other.
Okay, so mean square.
The MSE of both the training and testing error should be similar to each other.
Similar. Okay. Okay, got it. Thanks.
Okay, yeah, okay, thank you. Okay, others, have you all finished?
So I have also K-fold error.
Share your
Yes.
screen, please. K folds is not defined. Show me the K folds.
Any variable you have declared as k folds.
One second. Where is this K fold? No, it is not K folds. It is K fold. Remove the S from it. And the value inside K folds. Yeah, this is fine. Actually, I'm not able to see the font size is too small, so it was just taking some time. Now run this. Now it is okay.
Okay, fold is not defined.
Capital K. No, not there. And the next line. See, this is the name of the library, K-fold, which we have already defined in the libraries list of imports. Okay.
K is not defined.
K is not defined. So here the K is show me. It is small k because that is a parameter name, isn't it? Def. So there it is small k. Now it is fine.
It is not defined.
Show me the list of libraries. First line. Okay, where is K-fold here? We have not defined the K-fold. So from sklearn.model selection. So after the train test split, give a comma and include K-fold, capital K, capital F. No, not include. I mean, just key in the entry, capital K, capital F, OLD. And yeah, compile this, remove that from part there. Just compile this line, this cell. Okay, now come to the function.
CV tested.
Is it working now?
Yes, sir. K-fold working.
Huh.
CV test is not defined. Where is CV test?
Now what is the problem?
The CV test is not defined.
CV test is not defined.
Yeah.
CV, it is CV underscore test X. Prediction is done on the testing data, isn't it?
CV is not.
CV is not defined. Where is CV? Once again, show me the error. Where is? Okay, it is not CV.msc, it is CV underscore MSc. That is the name of the list that you have defined, isn't it?
Not different. Better.
So CV underscore MSC will hold the cross-validation errors. So define a blank list. And the last line before the return. CV underscore MSC dot append, not CV dot. Yes, now it is fine.
Thank you, sir.
Now run this line. 83.
Print.
Okay, it has run. Now you can print the value of CV1. There you go. But why is it printing only one value? That is because you have returned it inside the for loop. So take the return outside the for loop. Go
Okay.
to the function. वो जो return है, just take it to the left. It is inside the for loop. That's it. Now compile this.
Okay.
Now it is fine. So now take an average of all these values. You will get the mean MSC of the training data.
Okay. Thank you, sir.
Okay. Okay. Any other questions from anyone? Is this clear so far? Okay. So now the next thing that we'll do is plotting the best fit line. And we will do transformation of data because the model still has heteroscedasticity. So what are the two methods of transforming the data? That is what we are going to see now. Let me share my screen. So now plot the best fit line of model 1. So once again, we can write a function. So def plot best fit line. So the best fit line is going to be plotted for the actual data and the predicted data. So here I can write what is the actual data, what is the predicted data. So we have this function called reg plot, okay, regression plot, actual and predicted. Now I want to define all my actual values as dot. And I can give the color as, let's say, yellow. And then I want to show the best fit line. So that is part of line underscore keywords. And you define the dictionary. And I want to give the color of the best fit line as, let's say, red. Okay, so each time you build a model, you do the prediction, you want to plot the regression plot or the best fit line plot, you can simply call this function, and this need not return anything. Now plot best fit line. Now what is my actual data? It is test Y, and the predicted value is what is the predicted value? So predicted value okay, so predicted value comes from result 1. Okay, that is result 1. res1 dot predicted. Okay, so can you see the result on the screen?
Yes,
So
sir.
here you can see the best fit line. So you can put a title here also. For example, you want to give PLT dot title. So it's best fit line for model. And if you want, you can take one parameter also. So for which model you are plotting this? So best fit line for model plus the name of the model. So here my model is M1. So best fit line for the model M1. So here we can see that how my model is performing. Are you able to see the output?
Yes, sir.
Now, if you notice here, you will see this pink section here. You will see one pink border. Okay, these are known as confidence interval. Now, if you don't want this confidence interval to be seen, you can suppress that. By default, it will print these borders also. So if you don't want that, you just want the best fit line. So we have one parameter in this function of regression plot, and that is called CI, confidence interval. And here you can put the value as none. So this will suppress the display of the confidence interval in the graph. So now you can see that it shows a much neater figure. Okay, and you can make additional changes if you want. For example, when you are drawing the plot, I would also like to see how much is the error in this particular model. So you can pass the error component also. For example, I want to pass the value MSE. So here I can put the error. So these are some additional things that you can do to make your graph look as interactive as possible. So here I will write the best fit line for model is so much plus RMSE equals plus STR of NP dot square root of the error. Okay, and maybe I can round this to 3 digits after the decimal. And now if I look at the, okay, so here it says best fit line for model M1 with an RMSE score of 10.624. So this gives me a good indication that how the model M1 has behaved. So like this, you can store the details of every model with the model name and the error and decide which is the best model. Any questions from anyone?
Sir, I'm not able to see my graph.
Share your screen, please.
My screen visible? So here I have executed my function.
Okay.
And when I try to plot the graph, like this.
Okay, do one thing on the right hand side top. Can you close all these windows? Click on that 3 horizontal lines that you see on the right hand side. Click that and click on the close. Close this also. Close this also. Okay, now go to the menu option called view. Right side next to help. Click on panes and click on plots. There you go. You have it here.
So any palette we have to select, we can select it from here, right?
Yes.
Panes.
Yes.
Okay.
Now by default, the plot that you will get will always be on this particular window, which is called plots.
Okay.
Okay. If you want to change it, for example, I was getting it as a separate window, so that you have to configure it in the settings.
Okay. Got it.
Okay, but for now you can have it here. You can also save this window. So if you look at the graph output, you have all these options of cropping, saving, zooming. So you have this, if you look at the top menu, okay, so you have the copy option, save option. Okay, so all these things are available.
Yes. Got it.
You can zoom this also.
Okay. Because I thought it will get familiar with the screen.
Yeah. Okay, everyone, have you finished till this point?
Can you share that again? Need to see the last line.
Yeah, I'm sharing it. Komal, you were asking something sometime back that the sequence, what was that? What was it? Hello, have you all completed? Please confirm it, please. Okay, Keshav says yes. Others, Ankita, Kamlesh, Komal, Manish, Tejas. Okay, so now we'll go to the last part. So this is the transforming the data. So data transformation is usually done when your data is heteroscedastic and you want to convert it into a homoscedastic data or a homoscedastic model. So as I mentioned in the previous session also, converting this into a different format does not ensure that the model will become homoscedastic. The degree of heteroscedasticity is what you have to look at. Okay, so what are the different techniques that are available to convert from hetero to homo? So first is you can transform the features, leaving the Y as it is. And the second one is you can transform the Y, leaving the X as it is. So we are going to see both these options. So the first, so this is the transformation of data.
So this transformation of data has to be done before a homo or hetero, to when we figure out its homo or heterogeneity, or at the end, like after plotting this graph.
This is done at this stage. When you figure out, check for heteroscedasticity.
Mhm.
Okay, for here, for example, in this case, my model is heteroscedastic. Okay, so that means you can go ahead with the model building. Your first model will be the data as it is, and from here the subsequent models that you will be building, you will improvise. So you will do the feature selection, you will fix the heteroscedasticity, all those things will happen from model 2, 3, 4. So that's how it is, it will be done.
Okay.
So model 1 is, you can say that is a base model. And model 2 onwards, you are improvising on the base model so that you get better results each time. So the transformation will be done from model 2 onwards.
Okay. So first we have to get one model after getting its homoscedasticity or heteroscedasticity.
Yes.
And after that, we can transform it into homoscedasticity if it is heteroscedasticity.
Yes. See, again, it is not a rule. Okay.
It depends on the requirement or what it is.
So there are some standard, I would say, best practice methods. There are people who can, who directly transform the data. They feel that the data is, the numbers are too big. So they can do the transformation at the beginning itself. So it all depends on how the data is structured. So you are free to do whatever method you like first. So there is no rule as such that this has to be first, this has to be second.
Okay.
So transformation of data. So we are looking at the first transformation, which is transforming the features So here the y variable will be is unchanged, I can put. And the second transformation is transforming y and features are unchanged. And this is called as the Cox transformation. So we'll write again one function for transforming the features. So there are different types of transformation that you can do. Log transformation. So in the log itself, you have different varieties. I can have log base 2, log base 10, natural log. Then I have standard scalar, that is Z-score transformation, min-max transformation, square root transformation, inverse transformation. So all these are different transformation techniques. So which is going to work? So that you need to figure out by analysis. So I'm just writing a general function which will transform the entire data set. So transform data. So first is which data that you want to transform. Now, in this example, we only have the numeric columns. So even if you do not pass the column names, which is fine, because everything will be a numeric transformation. But if you want to make a generic function where I can use it for any data set, because we know that for doing a linear regression, my data can contain a combination of numeric data as well as categorical data. So you may want to use the same function there also. So there, if you have a categorical column, this function will not work. So you can put a columns as a parameter, which indicates numeric columns. And the third parameter that you can specify is what is the transformation type. So transformation type. So if I pass min-max as the transformation type, the transformation has to be a min-max transformation, and all the rest of the transformation types. So here you can write the transformation types. So for example, if you want to pass transform it into a min-max, so you can use this flag called min-max or z-score. Then I can have log base 2. Then I can have log base 10. I can have natural log, which is NL. Then I can have, let's say, for square root, I can have SQRT. For inverse transformation, I can have INV. And what else do we have? Natural log, square root, inverse. I think this is sufficient for now. Okay, so first thing that I'm going to do is I'm going to make a copy of my data set. So df1 equals data dot copy. Now the reason for this is whenever I'm making the change on the data, it is going to be passed by reference. So any change that I do will also affect the original copy. So I don't the original data which I don't want. So I want to do the transformation on a copy and return the copy back to the calling program. So I want to retain the original data in its right format. So that's why I have to do a copy. So first make a copy of the data frame. And now check the condition. If transformation type equals min-max, did I mention about the min-max function in the class?
No, sir.
What is the min-max function? What does it do?
Maybe gets the minimum and maximum value.
No. See, whenever you are doing a transformation, so the purpose of transformation is it has to be within a certain range. Okay, if you look at the data that we have now, every column has a different set of numbers. Some range, for example, the age ranges from 1 to 365. Some other component ranges from 2.5 to, let's say, 10.3. So you have different ranges here. But all these transformation techniques, especially the z-score and the min-max, it will ensure that every feature is transformed within the standard range. For example, z-score will transform the data between -3 to +3. And min-max will transform the data between 0 to 1. Okay, so this is the transformation technique. So the Z-score formula, you all know. Z-score is the data minus mu, that is the mean, divided by standard deviation, which is sigma. So if I have the data like this, 5, 8, 1, 15, 80, let's say 92, 6, 46, 10. So each of these values will be transformed into a Z-score, which will lie between -3 to +3. So first it will find what is the mean value. So find the mean of this and find the standard deviation of this, and then apply the formula for each of the value of X. Okay, this is the standard scalar. Is this clear to everyone?
Yes.
Then we have the min-max scalar. So min-max is a technique of transforming the data that lies between 0 and 1. So the formula is the data that you want to transform minus the minimum of that column divided by maximum of that column minus minimum of the column. Okay, this is the min-max function, and what you get is the min-max value. So this is what we are going to do in this function. Okay, understood? So first we are checking if the transformation type that you are passing is a min-max. Now, if you look at the list of libraries, we have one library for data transformation from sklearn import preprocessing. So I have written a comment here for data transformation. So this is what we are going to use, preprocessing. So the pre-processing technique that I'm going to use for min-max is pre-processing dot min-max scalar. Then use the second condition. If the T type is Z-score, then the pre-processing technique is standard scalar. Okay, so I'm creating an instance for min-max scalar and standard scalar as the pre-processing technique. And after that, I'll be converting them into its corresponding standardization using the formula. So first I'm going to transform using the other techniques as well. So else if the transformation type equals log 2. Now for log, I can directly transform the data. So here I will write df1 of columns equals np dot log 2 df1 of columns plus 1. Can anyone tell me why I put a plus 1 before converting it into a log? Anyone? Am I audible to all? So what is the purpose of converting the data by +1 and then converting it into a log? What is the use of that? See, there may be chances that your data contains a value 0. So if I take a log of 0, I will get infinity. So that is why I'm converting the zeros into ones and other numbers also by +1, so that I do not have this problem of the value INF appearing in my data. INF means it's an invalid number. I cannot do any processing. So if I do log of 0, I'll get INF. So if I do log of 0 plus 1, I will get 0. Is this clear to everyone?
Yes, sir.
So for log 2, I am using this technique. And I can do the same thing here for T type. I have log 10. I'll do df1 of columns equals np dot log 10. So that is the name of the function. In the NumPy library, I have a log 10 function where it converts the data into its log form of base 10. So df1 of columns, again, I'll use +1. Okay, now after this gets converted, I have to return the data frame. So I'll put return df1. And here I'll put return df1. Then the next else if it is natural log, then df1 of columns equals np dot log df1 of columns +1 return df1. Okay, now we have two more, square root and inverse. So if transformation type equals sqrt, df1 of columns equals np dot sqrt, df1 of columns return df1. And if it is inverse transformation, I can do df1 of columns equals 1 divided by df1 of columns. So here also I'll be doing 1 divided by df1 of columns +1, because if there are chances that some columns may be 0. So I cannot have a situation where I'm dividing 1 with 0. Okay, because in computer science, there is nothing called as divide by 0. It's an error. Okay, to avoid divide by 0 exception. And then return df1. Okay. And finally, in the else, you can have return invalid transformation type specified plus t type. Is the code clear so far? Now I can write transform the data into z-score or min-max. Because other transformation I have already done and I have returned the values, whereas for the z and min-max, I have only created the instances of the class called min-max scalar and standard scalar, because the technique to transform them is the same. So first I will create the scaled values equals pre-processing dot fit underscore transform. So fit transform is going to transform the data frame, which is df1, and which columns? I want these columns. So this will get transformed into the pre-processing that I have done, which can either be min-max or the z-score. So the scaled values will be the range of values. So if it is z-score, it will be from -3 to +3. If it is min-max, it is going to be from 0 to 1. And after that, I'll be assigning the transformed values back to its data frame. So df1.columns equals scaled values. And after that, I will use return df1. Now compile this. Is the function clear to everyone? Have you finished compiling this function? Please confirm it. Shall we move on, or are you still writing? Hello? You can message me. Okay, we'll take a break now. It's 11. We'll meet in 15 minutes. Meanwhile, you can compile this code and execute. And after that, we'll transform the data and we'll see how the transform data looks like. Okay, so we'll meet in 15 minutes. Hello, everyone. Have you all finished? Hello. Shall we continue or not?
Sir, can we continue in next session?
Next session.
Yeah, we have to practice this much first.
But have you all completed till this? Okay, so once the transformation function has been written, now we are going to transform the data. So the list of columns that we have, okay, that is going to be only the numeric columns. So here you can define a variable which is going to be train x dot columns. And these are the column names: CCOM, slag, fly ash, water, super, C aggregator, F aggregator, and age. Now I'm going to transform my data into its first form, which is min-max. So let me call this function transform data. The data is the concrete data. The list of columns is the columns that I have defined here. And then I have the transaction type. Now the first, sorry, not transaction type, transformation type. So the first transformation that I'm doing is the min-max. So I'm going to pass this parameter as min-max. And then conc underscore transformed. Okay, so now let me run this. So now you can see that I have the data which is transformed into its min-max form. So now let us do the comparison of these two data sets. So if I do conc dot head, so here you can see this is my original data set. And if I do conc underscore transform dot head, so here you can see this is the transform data. So you can see that the value 540 for CComp has now become 1. The value 332 has become 0.52. So for every data, the value has been transformed. So here you can see all the features have been transformed. The Y variable is as it is. Okay, so this is the data transformation, but the Y value is as it is. Is this clear to everyone? Now, similarly, I can do the next transformation. So the data is concrete. The columns are calls. And here I have the Z score. So now if I use conc transform.z score, so here you will find the data is transformed between -3 to +3. Now, how do you build the model now? So now you have two separate data. You have three data sets. This is the original data set with which we have built the model M1. Now you have the min-max data set. So using this, you will be building model 2. Now you have the Z-score transformation data. Using this, you will be building model 3. So for every transform data, you are going to build a new set of model. So the code for the model is already there. So we just have to call those functions and call the model as M1, M2, M3, etc. That is the reason why I wrote functions, so that you don't have to write those code again and again. Call once and do all the predictions, cross validations, etc., etc. And then you can get a good result based on the comparison of the different models. Any questions from anyone? Ankita, Kamlesh, Keshav, Pomal, Tejas.
Sir, I missed last 15 minutes session, so I'll just go through it and let you know if I have any questions.
So do you need some more time to finish this?
Yeah, at the end, can you share the sheet? Like I missed last 15 minutes session.
Yeah, I will share this. I'll upload this, but whatever we have done in the class so far, were you able to do this? That is what I was asking.
Yeah, before this transformation thing, yes, I was. That
Okay.
if else condition, the last transformation function, I have to go through it. Before that, yeah, I was able to understand.
Okay, so 10 minutes, is that sufficient? 15 minutes for you to go through it?
Sure. Yes.
Okay, so I'll just leave this screen as it is. You go through that and compile it and let me know if you are able to understand and execute all these things.
Okay.
Okay, have you all finished? Please confirm.
Yes.
Okay. So let us continue. So here you can see that with every transformation, I am creating a new set of data. And now I can use all the above methods, that is build the model, splitting the data, and then build the different models and see how my model gets built with every transformation. Okay. So I'll just do one more transformation, that is a log transformation, and then we can go to the next part. So here if I do transform data, and I'll use the log. Okay, so if you look at the conc, okay, so here you can see that this is a log base 2 transformation. So features are transformed, the y variable is as it is. Now we'll come to the last part of this section, which is transforming the y variable, but leaving the x as it is. And this is called as Box-Cox transformation. So if you recall, the concept of Box-Cox transformation is, I'm going to find a value called lambda. So this lambda value, a very small number. So if I convert the y variable from its existing form and I raise this to the lambda, the transform data will have a normal distribution. Okay, that is the definition of the Box-Cox transformation. So this transformation is known as the Box-Cox transformation. So here the y is getting transformed, whereas the x remains as it is. Now I'll be building the model where the y will have the Box-Cox transformed values, the x will be as it is, and the same set will be repeated. And building the model, checking for heteroscedasticity, all those things will remain exactly the same. So let's do this part. Now tell me one thing. If I have my original y, this is original y variable, and if I have a Box-Cox transformed y variable, and I'm using this to build the model, now the predicted value will be in which form? Will it be in the original y form or will it be in the Box-Cox form? Right, it will be in the Box-Cox transform format. Okay, so now once I get my predictions, which will be in the Boxcox format. I need to convert this into the original format. Okay, only then I can find out how my predictions are. So I'll be comparing the Boxcox for converted format and the original format. Okay, so we'll do this exercise and that will be the last in this chapter. Okay, so to transform the y variable into the Boxcox transformation. So we have we have taken this library called stats from scipy.stats. So this is where I have the Boxcox transformation. So we can write a comment here. Boxcox transformation. So stats dot the function name is Boxcox. So stats dot Boxcox. So this will take only one parameter, which is the train y. Because I'm transforming only the y variable. So this will contain one parameter, which is the Boxcox. So now you will see that this function has transformed the y variable. And if you look at the return value, it will contain two sets of values. The first value will be, so this returns two values. The first is the converted data, converted y, and the second output is the lambda value. Okay, so let us look at the output and then you will understand. So if I print the value of Boxcox transformation, so print BCT. So here you can see that it is converting the y variable, and at the same time it also has the lambda value, which is the second value in the output. So I'm going to call this as Boxcox y equals BCT of 0 and lambda equals BCT of 1. Is this clear to everyone? Okay, now if you want to see the difference between the two values, so I can print them out. So difference between the original y and Boxcox y. Okay, so I'm just going to print them out. So pd.data frame. You can write original y, which is test y. And then I can write Boxcox y, which is BC underscore y. So it should be train y, not test y. Okay, so now see the difference. The original Y 29.07, 49.77. And when you transform this number, you get the output in the transformed format, which is 10.1, 14.4, 13.04, etc., etc. Is the output clear to everyone? So now I can build the model using the train X and Box-Cox transformed Y as the dependent variable. Then test the model on the test X. The predictions will be in the Box-Cox format. This needs to be reconverted into the original form. Okay, so just like you have converted the train Y into a Box-Cox, similarly, you will be converting the test Y into a Box-Cox format. Then do the prediction and then convert the values into its original form. So can you do this exercise now and tell me? Or I'll tell you how to convert the Box-Cox format to its original form. So I'll write this code also, and after that you can do the model building for both the techniques, that is method 1 and method 2. Okay, so let me write this code, and after that you can do this exercise. Now let us take this value, which is the Box-Cox format. So I'm going to create one variable called Box-Cox format. And what I want is the result 29.07. Okay, so just remember this formula and you can use it with any data that you want. So this is the Box-Cox format number. So the formula is np.exp, that is the power function, the log of the Box-Cox format, okay, log of the Box-Cox format multiplied by the lambda value plus 1. Okay, divided by the lambda value. So if I run this function, you will get back the original number, which is 29.07. So here you can write original format equals so now if I print box Cox format, so you can see here 10.15 is the box Cox format and the original format is 29.07, and that is exactly what I have also in the data frame here for the record number 983. Okay, so now you have both these techniques. The first technique of transforming the features, leaving the Y as it is, by transforming the data into one of these formats, then building the model. So that is method one. Method two, box Cox format, where you are transforming the Y variable, leaving the features as it is, and then building the model. So I have given you both these methods. So your assignment will be try both these methods, build one or two models and compare the models in terms of its performance, which is performing the best. And after that, you can fine tune the model in terms of hyperparameters and feature selection. Okay, so do this exercise. And if you have any questions, let me know. Ankita, Kamlesh, Komal, Tejas, are you able to write the
Yes.
code, execute and understand? Is that all done?
So एग्जीक्यूट किया है, अंडरस्टैंड नहीं हुआ क्योंकि ऑनलाइन से कोई जो कंसेप्ट है वो क्लियर नहीं हो रहा अभी. फेस टू फेस जैसे हो रहे तो अभी तक नहीं हो रहे इधर, यही इशू है.
अच्छा, तो यहाँ पे अभी what about the others? Can you just confirm if you are able to understand or not? ठीक है, you can you do this exercise and let me know if you're facing any issues. Okay, so I'll leave the rest of the time for you to do this assignment. Tomorrow we'll be starting with the logistic regression. So ensure that you do these assignments and finish it off today. And if you have any questions, then you can ask. Yeah, I'm sharing this file. I have shared the code. अरे अंग्रे I have shared the file on the chat. You can have a look at it, please. Okay, and I have also given some assignments. Want you to finish that before we can start the next one tomorrow, which is logistic. And if you are having any issues, do let me know.